Okay, please say again.
Okay, so I was just trying to say, if the parameter is a studying and you are rejecting a non-hypothesis, that means thinking maybe you cannot generalize the results the result you have, the result of the studying.
Okay, okay. All right. Any other remark on that? So again, we know we are carrying out hypothesis tests. We are trying to see if there's statistically significant difference between the average performance, average score of Nigerian students and average score of British students in maths. Okay, this is a fictitious data from a fictitious institution, right? So we've already seen what the t-test is. We've seen what one sample, test sample, and independent sample t-test represents. Okay, so and in our example, we are setting our alpha, which is level of significance to 5%, 0.05. So we said to get the uh, to compute t-test, let's just take that again. To compute t-test, simply say equals t.test, use the t.test function. It's asking for array 1, that's the first data set. You give that, comma. Now it's asking for array 2, that's the second, which is for the British student. Give that, and then the tails. In this case, we are dealing with a two-tailed test. And then the type, we are dealing with a uh, two sample test or independent sample. So it gives us that figure 0.011819 as our p-value, which we computed here earlier. P-value, okay. This is our p-value in this case. So we can see that the p-value is lower than alpha, level of significance. So we are going to reject the null hypothesis. What are we rejecting? This one, right? This is the null hypothesis, isn't it?
Yes, sir. That the British and Nigerian students are the same, have the same performance.
Exactly. That's the one we are rejecting now, which means they are not equal. Rather, not that we are rejecting this. Okay. Uh, that's to say, we are rejecting this, which means this alternative hypothesis stands, right?
Yes, sir.
So, which means there's statistically significant difference between the mean scores. Okay. Yeah. So that's that. But there's another way you can do this. You can do it through by using the data analysis tool. Data analysis. Okay. In the data tab, click your data tab. Click data analysis. If you don't have data analysis here, then you have to activate it. Just go to your file menu, click on options, click on add-ins.
I can't see your screen, sir.
At all. Hold on. So I was saying that instead of using the t.test function like this, A better way of doing this is to go through to utilize the data analysis tool, right? You click your data tab, open up your data tab, you see the data analysis. Or if it's not there, which means it is yet to be activated. Okay, so you click on your file menu, click on options, click on add-ins. You see the analysis tool pack. Select that, that's an Excel add-in. Make sure Excel add-in is selected here. Click go, and then just tick it here. Tick it, and then click on OK. When you do that, it will appear in the data ribbon. So can use it for our t-test. It's better as it even gives a more robust output. Okay, just click on data, click on analysis, data analysis. It opens up this dialog box. Look for t-test. What kind of t-tests? Let's say we are doing t-tests, two samples, equal variance, assuming equal variance. Click on that. Then for range 1, the first range, that's um, the first data set, first sample. Click in the second box, test box, where you have variable 2 range. That's the second sample. Okay. Then these labels, if you notice, I didn't select the headings. Therefore, I have to deselect. I'm not supposed to select this. If I select labels, which means I also included the heading, right? Well, I didn't do that, so this needs to be deselected. This is the significance level you are using, which in our case is 0.05. Then, where do we want the output to be positioned? Hypothesize mean difference is 0. Why? Because um, our our null hypothesis says x1 equals x2. That's the same thing as saying x1 minus x2 equals 0, isn't it? That's what it's about. Okay. Then output range. Where do you want the result to show? Either you put it in a new sheet, new workbook, or output range. Output range means you want the result to be displayed within this sheet. Okay. So let's say I want my result here. Okay. Output range. I just click where I want the results. And then I click OK. Input range must contain at least one data point. Okay. What happened to that one? Okay. So it gives us the results right away. That's the result. Okay. So that's the result, right? So you see that this one is more detailed than what we got before. What we got before was just this, just this, right? By using the t.test function, it gave us this. Why? Because that's the most important variable you need for your interpretation. Is this clear to everyone? Okay. But this one is more robust because it gives you everything. Tells you the mean, the actual mean of the two variables, which we can see here anyway. It gives us the variance of the first variable, variance of the second variable. Gives us the number of observations, 16, 16. The pooled variance, that's combining both of them. Then it gives us the hypothesized mean difference, okay, which I've already explained. It gives us the degree of freedom. Degree of freedom is what? 16 minus 1 plus 16 minus 1. That's 15 plus 15, which is 30. You know, it gives us the t statistics. This is the t value itself, the t statistics. You know, if we were doing manual statistics, we would have needed to use the statistical table, calculate the value of t, and then use the table to check, you know. So this is the t value we would have gotten. They will now have to use would have had to use the statistical table to trace and see the corresponding p-value. Okay, but since we are using a computer to do this, we are using a software. We don't need to go through that route. It gives us the p-value right away. Okay, T critical is this, which means what that means is the cutoff, the borderline is this, the borderline. Okay, so this one actually corresponds to 0.05, p of 0.05. So now you need to know that when your p, we already have explained that when your p value, calculated p value, is less than the significance level, you reject the null hypothesis. Okay, but if you want to use the t statistics given, when your t statistics is greater than the t critical, you reject the null hypothesis. But to avoid confusion, just leave that one. Focus on the p. Okay, when your p value is less than alpha, reject the null hypothesis. So always remember that that's the key. Hope everything I've explained is clear. Are we on the same page? Are we on the same page?
Yes, sir. Same page.
So an alternative to t-test is the z-test. Go to data analysis, say it's the z-test. But when you are doing the z-test, you will need to input the variance. You have to know the variances in order to do a z-test, right? So that's why one of the reasons why t-test is more. But in the case of t-test, you don't need to supply the variance. You don't need to supply the variance. Okay, so let's do a z-test and see what it's going to give us, right? Let's do a z-test and see what we'll get out of this. So it's asking us for the first range. Let me select the heading this time. Second range. That is the second sample. Hypothesized mean difference. You see, basically the inputs are the same, apart from these variances. The variance of the first one known, let's say, is 291.3167. Variance of the second one, 356.8625. And then, hope you know why I'm clicking the labels this time. You know why? Because I selected the heading. Okay. Then the output range, I want the result to be displayed here. Or here, so we can see the results side by side. Okay. All right, so I want you to interpret this result for me. Interpret the result.
It's the same thing. We are rejecting the null hypothesis because the z is less than for the two tails because this is what we are looking at.
Yeah.
Yeah. So for the two tails less than the 0.05. So
Okay.
So we are rejecting the
So
null
here
hypothesis.
also we are rejecting the null hypothesis. Thank you. I hope it's clear to every one of us. Is this clear to everyone? Yes or no? Is it clear? Hope we got it. Any questions? Okay. So that's that. So it's something like this. Can you see it looks like the normal distribution somehow? Okay. T distribution is a continuous probability distribution of the z-scores when the estimated standard deviation is used in the denominator rather than the true standard deviation. The T distribution, like the normal distribution, is bell-shaped and symmetric, but has heavier tails, which means that it tends to produce values that fall far from its mean. Okay. T-tests are used in statistics to estimate significance. So it approximates the normal distribution. That's just what I wanted to show you. The what is called the T distribution. Okay, now this is a one-tailed test, right? It could have been this is a two-tailed test. It could have been a one-tailed test. Okay, let me give you an example of a one-tailed test. A situation where it is believed that Nigerian students are better, but one is trying to dispute that. Okay, so okay, but first of all, let's just pause here for a while. So we'll continue the one tails shortly.